The difference between parallel and asynchronous programming may seem subtle. In essence, asynchronous programming allows for a way to run a continuation as the operation completes. The asynchronous operation runs in parallel and doesn't block the current thread that starts it. The purpose is often to perform an I/O operation, meaning reading from disk or calling a web API. With the task in the task parallel library, we've got the capability of doing both asynchronous and parallel programming. I'd like to think of the task as a way to represent work that needs to execute somewhere other than the calling context. We know by now that when we use parallel invoke, parallel for, or parallel for each, we can distribute work across different cores and threads available on that system. Calling these methods block the current thread until the entire operation has completed. Wouldn't it be great if we could move that entire operation into a different context and then somehow subscribe to when all of that has completed? Sounds familiar? It definitely should. If we simply wrap the entire parallel invoke call in a new anonymous method which is passed to task.run, this would mean that the calling thread won't be blocked. This also means that we can use the async and await keywords to say that we'd like to introduce a continuation, which is only executed once all the parallel operations have completed. You can run this, and the application certainly behaves as it did in the previous clip, although the user experience is greatly improved, especially because the UI doesn't freeze. However, this also introduces a bit of a problem. When we move the call to parallel invoke to another thread, that means we wouldn't have that thread available to work on, which ultimately means that it's not as efficient as it could be. It really comes down to your intention, and sometimes you have to make the trade-off to allow a certain user experience. Users may be fine with an operation taking a little bit longer, given that the UI doesn't freeze. If a UI freezes or locks up, I know from my own experience that I'm pretty quick to kill the process. The change you have to make to the code to combine asynchronous and parallel principles are really small, and it's pretty easy to combine these paradigms. This is hugely thanks to the task parallel library. If you had to build this on your own, using the lower-level threading, or even using the thread pool to queue some work, you'd end up with some really complex and error-prone solutions. Not only do we get help from the task parallel library, let's not forget about the async and await keywords that also uses this internally to help you build better code. We've improved the processing of the stocks. We have offloaded the UI thread from the work. But what happens if the parallel operations fail? We need ways to handle potential exceptions and problems. Next up, we're going to learn about how to handle these exceptions.